So in this video, my brothers and I experimented with Coca-Cola and Mentos. We tried it with Mentos that were whole and cut up, and with regular Coca-Cola and Diet Coca-Cola. The first two bottles on the left were used with 2 whole Mentos, and the 2 bottles on the right were used with 2 Mentos that were cut up, and that goes for both the regular and diet sodas. As you can see, my little brothers kind of had a difficult time getting the cut up Mentos to go into the Coca-Cola bottle, so the whole 2 Mentos may not have actually gotten into those bottles. However, you could see that the reactions were different between the Mentos that were cut up and the Mentos that were whole. These next few photos show the bottles as they appeared from left to right in the video to show you how much soda was left after the reaction. Here we are doing the exact same thing that we did in the first round, but we are using Diet Coca-Cola instead, and you can see that the second bottle from the left, one of the Mentos got pushed out of the bottle, so we had to put that back in, and that is why that reaction took a little bit longer than the rest. Again, the following photos show the bottles as they appeared from left to right on the screen. In both the case of the regular Coca-Cola and the Diet Coca-Cola, the bottles that had the 2 whole Mentos ended up with less soda left in them. That means that the bottles that got the whole Mentos lost more soda than the ones that got the cut up Mentos. Now let's review why this reaction happens. Soda is carbonated, so that means that there is carbon dioxide gas, which is sometimes abbreviated CO2, that is dissolved in the water that makes up the liquid part of the soda. When the carbon dioxide is dissolved in the water, it's kind of like they're holding hands, but the carbon dioxide isn't super happy about it. It doesn't really want to be there. The water, on the other hand, doesn't really mind. Now, what about the Mento? If we look at the Mento under a microscope and we zoom in a whole lot, we see that the surface that appears smooth to our naked eye is actually very porous, or in other words, it has a bunch of little holes in it. When we add the Mento to the carbonated soda, all of those holes in the Mento give the carbon dioxide something else to hold on to other than the water. The Mento comes between the carbon dioxide and the water molecules and breaks them up. This happens very quickly, and it rushes to the top and causes the eruption of soda that we see. Because we start with carbon dioxide, water, and a Mento, and we end with carbon dioxide, water, and a Mento, this reaction is considered physical and not chemical. So why do the whole Mentos react differently than the pieces? Well, that's based on their weight. The whole Mento sinks all the way to the bottom of the bottle, reacting with more carbon dioxide molecules on its way down, whereas the pieces don't always reach directly to the bottom, or if they do, they don't get there as quickly. That causes less carbon dioxide molecules to be freed from the water molecules, and the reaction is less intense. As for the question of diet soda versus regular soda, there really was no difference in the reactions. The only difference I could find from looking up information online is that diet soda usually makes less of a mess because the substitute for the sugar is less sticky. Here's a little blooper video of me trying the reaction with a 2 liter of soda instead of a little bottle. It's a little bit more intense. I hope you guys learned something from this video, and don't forget to fill out the form so you can get credit for class.